Hello viewers, you're welcome back to my channel. This is the second part of the video lessons on circle geometry, and in this video lesson we are going to look at theory out of the several theorems we have in circle geometry. So in circle geometry we have theorems just as we have laws in other aspects of science. Now for you to understand this video lesson and subsequent video lessons on circle geometry, it is important you get yourself familiarized with some basic terms of a circle. And what are those terms? We have the circumference, the arc, the diameter, the radius, a segment, a sector, and a chord. So for you to understand this, you can check out the part 1 video lesson on circle geometry. So the first theorem we are going to consider here states that a straight line drawn from the center of a circle. So we have a center. Let's mark it as point O. So a straight line which is drawn from that center to the middle of a chord. Remember that a chord is a line which runs from one point of the circumference to another point but does not pass through the center, because if it passes through the center it is no longer a chord but a diameter. So again, a straight line which is drawn from the center of a circle to the middle of a chord, that's the midpoint of this chord. So let's say here's the midpoint of the chord. So a line which runs from this center to this midpoint is at right angle. And what does a right angle means? A right angle simply means an angle at 90 degrees. So in an exam you could be given something like this, a shape, and you see this symbol. Now you may wonder what is actually here. Whenever you see this actually means 90 degree, or we can best say it is what? Perpendicular. So two lines that meet at 90 degree are said to be perpendicular. So I have a line, then I have another line that meets it at 90 degree. These two lines are said to be perpendicular. So in this theorem, a straight line which runs from this center, let's say O, to the midpoint of a chord is at right angle. So this is 90 degree. On the other hand, it is also 90 degree. Remember this, that when you have a straight line, if you have a straight line, the angle on the straight line is equal to 180 degree. So in this case, this line from the center passes through the center of this angle to give one side as 90 degree and the other side as 90 degree. So in essence, our first theorem which we are going to consider in this video is that when you have a straight line which runs from the center of the circle to the midpoint of a chord, but note a chord is not a diameter, is at right angle to that chord. So the second theorem is just a continuation of the first theorem. So the second theorem states a straight line drawn from the center of a circle. Again, we have the center of a circle. This is center of a circle. Let's say O, which is drawn from that center to a chord, but that line is drawn perpendicularly. So again, the perpendicular lines are lines that meet at 90 degrees. So this line, they meet at 90 degree. So a line which runs from the center to a chord bisect. Now some person might be wondering, what does bisect means? Bisect. So let's look at this word bi. Bi means two. Like you have the word bicycle, two ways or two cycle. Then sect just simply means divide or division. So what does this mean? A line which is drawn from this center to this chord divides this chord into two equal halves. So if this chord originally was, let's say, 8 centimeters, so we have this chord, but once this line goes through this chord, this side is 4 cm, this other side is 4 centimeters. So in essence, when you have a straight line which runs from the center and it runs perpendicular to the chord, it will divide that chord into two equal parts, just as it will also divide the angle into two equal angles. That's 90 on one side and 90 on the other hand. So moving on, we have our third theorem. Now we call them theorem 1, theorem 2, theorem 3. Now in real sense, they may not always follow this order. It's not like what we have, Newton's first law of motion, Newton's second law and then Newton's third law, that Newton's first law is different from Newton's second law, and Newton's second law is different from Newton's third law. So when you are asked to state Newton's third law, for example, we always say that action and reaction are equal and opposite. So I can't go and define Newton's first law as action and reaction are equal and opposite. So there's a definite order for that law. But in this theorem, there's no definite order. So my theorem 3 can be my theorem 1. So when you are asked for theorems, just simply try and think of the ones you can remember. So there's no definite order, as in theorem 3 must be equal chord of a circle at equidistant from the center. No, you can see in your own textbook, theorem 1 may just be equal chord of a circle at equidistant from the center of the circle. Now that does not make that textbook wrong, or whatever source you are getting that knowledge from is wrong. So it might be scattered anywhere you come across it, but just know that the theorems are the same and they follow just the same pattern. So now let's come to theorem 3. Theorem 3 says that equal chord of a circle are equidistant from the center of the circle. Now what does this mean? Now we have chords, but in this case the chords are equal. So how are they equal? In real sense, they are equal in their length. So if I have a chord, let's say a chord on this side and a chord on this other hand, so what makes them equal is their length. So let's say this is, let's say 10 cm, for example, that's this particular chord 10 centimeter. Then this other chord is also 10 centimeter. Again, you have the center of the circle. So what does this theorem tells us? It tells us that provided the chords are equal, and how can they be equal? In length, they are at equidistant. Equi means equal. So they are at equal distance from the center. So what does it mean? If this chord is 5 cm from the center, 5 centimeter, because this other chord is also equal, it's also going to be 5 centimeter, 5 cm. No matter how the chords are drawn, if I have a chord here, let's say this chord is 6 centimeter, 6 cm, this is the center of the circle, and I have another chord, let's say this chord is also 6 cm. The distance from here to the center, let's say 3 cm, will also be that same 3 cm from here to the center of the circle. So in real sense, chords that are equal in length, that's how they can be equal, are at equal distance from the center of the circle. So don't forget that. So we are going to look at some practice questions just to make sure we understand the various theorems we have looked at so far. First question says, in a circle of radius 5 centimeter, two equal chords, each measuring 8 centimeter, lie on the opposite side of the center of the circle. The question simply says, find the distance between the two chords. Now, when you are given a question like this on circle geometry, and it is in a word problem format, the first thing you are advised to do, if it is in a written exam, you should sketch or draw. So I'm going to draw. Now, we have a circle of radius 5 cm. So let's take this as a circle. That is circle of radius 5 cm, but I'll come back to that. Now it says two equal chords. Now what makes the chord equal? Because they both measure 8 centimeter. Now, and they lie on opposite side. What does it mean? If this is your center, this is one side, this is the opposite side. Or if I'm taking this side, this will be the opposite side. So we have a chord on this side. This chord is 8 centimeter. On the other side, that's on the opposite side, we also have another chord of 8 centimeter. So these are two chords on opposite side. Now you have a radius. You know what a radius is? That's why it is good you understand your various terms. A radius is a line that runs from the center to any point of the circumference, but make sure it touches one of the end of your chords, so that at the end of the day we can form a triangle. So it is very important that when you are drawing your radius, draw your radius from the center to the end of any of your chord. So that's a radius. So radius can also run from here to here. That's also a radius. Now your radius measures 5 cm in length, 5 centimeter, 5 centimeter. Now the question says find the distance between this chord. That's from here to here. So we are finding distance from here to here. Now, but if you look at this question, this side, I'll shade one portion. This side is a triangle. So we can cut that triangle out. So I'm going to have something like this. So I have something like this. I have this. then I have this. Now remember, this line that runs from this center to this point cut this 8 centimeter into 2 parts. So this is 4 cm, then this other side is 4 cm. Remember our theorem 1 and theorem 2. So this is going to be 4 centimeter. Remember, this is the radius 5 centimeter, but we don't know what this side is. Let's take it as x. So we are going to get x first. So now we are going to solve like this. I'm going to draw that triangle again. So we have this, we have 4 cm, 5 cm, and then x. Now in solving these questions, you should always remember your Pythagoras theorem, which says that hypotenuse square, that's square of the hypotenuse, is equal to square of the opposite plus square of the adjacent. So when doing that, try to identify your side. This is the hypotenuse, h. Then any side can stand as your opposite in Pythagoras theorem, and then this adjacent. Any side can be your opposite and adjacent, but always identify your hypotenuse, because your hypotenuse is constant in Pythagoras theorem. So our hypotenuse in this case is 5. That's 5 square. Opposite is what we are looking for currently, x, plus adjacent is 4. That's 4 square. Now 5 square is 25. X square is unknown. Then 4 square means 4 times 4, and that's 16. Then you are going to collect like terms. This is 25. If I take plus 16 to this other side, it's going to be a negative 16 minus 16 is equal to x square. And 25 minus 16 is 9. So 9 is equal to x square. Now when we do that, we can take the square root of both sides. So we want to take the square root of both sides. X is equal to 3 centimeter. So now we have gotten this part. So this part from this center to this end is 3 cm. So automatically, remember, equal chords are at equidistance from the center. So automatically, this other side is going to be also 3 centimeter. So the total distance from here to here will be 3 plus 3, and that will be 6 cm. So therefore, the distance between both chords is what? 6 centimeter. The distance between both chords is 6 cm. So do it to always memorize your laws and make sure you find them handy whenever you see a question on circle geometry. So look at the other 2 questions we have. So the second practice question reads, a chord is 32 centimeter long. The distance of the chord from the center is 12 centimeter. Calculate the radius of the chord. So whenever you get any word problem question from circle geometry, it is important you sketch a circle or just draw something to illustrate the question, especially in a written exam. So now we have a circle, and then we are going to fit in all the different statements into the circle. So we have a chord which is 32 centimeter in length. So this is the chord 32 centimeter. And every circle has a center. Now the second statement says the distance of the chord from the center, that's from the center to this chord, is 12 centimeter. The question says calculate the radius. A radius is any line drawn from the center to any point of the point on the circumference. If you draw this, you are right, because this is a radius from the center to the circumference, but it is ideal you always form a triangle. Again, for any question in circle geometry, especially for the first 3 theorem, always ensure that you get a triangle. So I'm going to use this instead as the radius. So this is the radius now. So radius, again, see from the center to any point of the circumference. So the question says calculate this radius, which is arrow. Now looking at this, you have a triangle. So this is a triangle. This part is a triangle. So we are going to take that part out and solve. So before we do that, remember this line runs to the midpoint of 32 centimeter, and if it does that, this is going to be, one part is going to be 16 cm, then the other part is going to be 16 centimeter. So we have something like this, we have this, we have this, and then we have this. So half of the chord is 16 centimeter. This part is 12 centimeter, and then we are looking for the radius arrow. So we are going to simply apply Pythagoras theorem in solving that question. So again, we have 16 cm just as we have there. 12 cm, and then our radius. So Pythagoras formula is hypotenuse square is equal to opposite square plus adjacent square. Now you should identify the various parts of your triangle. So this is the hypotenuse. Now when you have identified hypotenuse, any side can be opposite and adjacent. So let's take this as opposite, and then let's take this as the adjacent. So I'm going to plug in my various parameters. So hypotenuse is the radius, which we don't know. Opposite is 12 square plus adjacent is 16 square. So r square is going to be equal to 12 square, which is equal to 144, plus 16 square, which is equal to 256. Now when you add up that, you end up getting 400. Now some persons might decide to take the square root of both sides. That's, you take the square root of both sides. Now when you do that, this square root will cancel or eliminate the square. So we have arrow. Then square root of 400 is 20. So your final answer is 20 centimeter. Or some persons might choose to move this square to this other side. Now when that square crosses the equality sign, that's this equal to sign, it turns to the square root. So arrow is equal to the square root of 400, which will also end up giving you 20 centimeter. So the radius of the circle in this question is 20 centimeter. So the third question read, PQ is a chord of a circle. So let's just draw that chord, which is PQ. So we have a chord PQ. So PQ is the chord of a circle. The radius of the circle is 10 cm. Again, always ensure that your radius is drawn from the center to the end of a chord so that you can get a triangle. So this radius is 10 cm. So let's take this down, 10 cm. And the distance of the midpoint of the chord, so let's say this is a midpoint of the chord, from this center, that's from here to here, from the midpoint to the center, is 6 centimeter. So this is 6 centimeter. The question says calculate the length of this chord. So you are looking from the distance from here down to here, but we can only get this part first. Let's say x, that's this part first. So we are going to get x first. So now we have a triangle again. So that's why it's important you always get a triangle, so that you can easily apply the Pythagoras formula. So we have x on this part, we have 10 cm on this side, and then we have 6 cm on this side. So we're going to solve that using the Pythagoras formula. So we have this, we have x, we have angle 90, we have 10 cm, and then we have 6 cm. Now again, Pythagoras formula is the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. So you identify the sides. Automatically, this is the hypotenuse. An easy way to know your hypotenuse, it is the side just facing your angle 90 or the right angle. So if that's the hypotenuse, any side can be opposite. Let's take this as opposite. Any side can be adjacent. Let's take this as adjacent. So hypotenuse is 10, but that will be 10 square. Opposite is 6, that will be 6 square plus adjacent. We don't know, so let's say that as x. So 10 square is 100. 6 square is 36 plus x square. So we are going to take 36 to this other side. So it's going to be 100 minus 36 is equal to x square. So we now have this to be 64, because 100 minus 36 is 64 is equal to x square. Now when we take the square root of both sides, the square root of x square is x, and the square root of 64 is 8. So x is equal to 8 centimeter. Now coming back to this diagram, we have this part to be 8 centimeter. Automatically, this other side is going to be 8 centimeter. So therefore, the length of the chord, is going to be 2 times of what we got. So the length of the chord will be 2 times 8 cm, or you can as well say 8 cm plus 8 cm. In all, you end up getting 16 centimeters. So automatically, the length of the chord is 16 centimeters. So lastly, here's a quick win quiz for you. So do well to attempt this question. First correct answer in the comment section, gets a gift from me. So the question read, a chord PQ of a circle is 14 centimeter long. The radius of the circle is 8.5 centimeter. Calculate the distance of the midpoint of the chord PQ from the center in the circle. So do it to leave your answer in the comment section, as the first correct answer will get a special gift from me. So viewers, I hope you enjoyed this video lesson and you learned something from this video lesson. Do it to share this video lesson with your friend, and also give this video a thumbs up. And if you have any question, comment or suggestion, do it to leave them in the comment section of this video. So till you get to see my next video, do have a wonderful time.